Hello, how are you doing? This is Mike Johnston here, and in this video we're going to discuss the multiplicities of a zero. And then the idea of a multiplicity is how many times a zero occurs. And you might think to yourself, that's only going to be once. It's only going to occur one time. However, in the polynomial form, it may be slightly different. So let's look at an example. Let us say I said f of x equals to x minus 2 times x minus 2. X minus 2 times x minus 2, if we want to find the zeros, we're going to set this equal to 0. And since we're multiplying these two factors together, we're going to get x minus 2 equals to 0 and x minus 2 equal to 0. And since they're the same factor, we get x equals to 2 and then x equals to 2. So notice here, this 0 algebraically occurred twice. Graphically, what happens is that at positive 2, my graph comes down and it touches the graph at x equals to 2 and then it bounces back off. So the 0 graphically only occurred twice. However, graphically only occurred once. It only occurred once. It touched at 2. However, algebraically it occurred twice. It occurred here and it occurred here. So let us discuss another example. Let us say I said f of x equals to x minus 4 times x minus 4 times x minus 4. If I wanted to find the zeros here, we would set x minus 4, 1, 2, 3. Remember, if we want to determine the exponent, we could say x minus 4 cubed equal to 0. Remember, if we have x minus 4 times x minus 4 times x minus 4, that's really going to be x minus 4 raised to the third power. Raised to the third power to make sure we can see that clearly here. So raised to the third power. So if I want to solve this, I would raise the left side to the 1/3 power to counteract that exponent. But whatever I do to the right side, I have to do the left side. So I would also raise the 0 on the right to the 1/3, which really doesn't make a big difference. Here we would get x minus 4 equal to 0. I would add 4 on both sides, and I get x equals to 4 again. However, how many times did the 0 occur? How many times did this 0 occur? So graphically, if we look at this graphically, we're going to have a curve that starts down here and it planes out and touches at 4 and then continues on. It looks something like that. It's not a perfect depiction, but it looks something like that. So in this circumstance, it actually crosses the x-axis. In the last circumstance, it just touched the x-axis. But how many times did this 0 occur? Let's think about it. It occurred 1, 2, 3 times. Therefore, we would say the multiplicity of x equals to 4 is 3. The multiplicity of x equals to 4 is a value of 3. It occurs 3 times. It occurred one time here, it occurred another time here, and it occurred another time here. So it occurred 3 times. If we go up to this graph, the one prior, if we asked for the multiplicity of this graph, so let's say I asked for not the multiplicity of the graph, multiplicity of x equals to 2. If I ask for the multiplicity of x equals to 2, notice here it occurred once, it occurred twice. Therefore, that equals to a value of 2 as well. So it occurs twice. The multiplicity is 2. So the multiplicity is how many times that 0 occurs. So let's say in this example, I asked to determine the zeros, I always spell that wrong, zeros and multiplicity of f of x. So let us say that f of x equals to x minus 4 squared times x minus 3 to the 4th power. So if we want to find the zeros, we're going to set this polynomial equal to 0. So now we have two terms being multiplied, and we can split them up. And we can set them both equal to 0. But here's the key. Here's the key. Notice here, this has an exponent of 2. This exponent is going to be indicative of the multiplicity. Notice this exponent has a value of 4. This will be indicative of the multiplicity of the 0 that arrives from solving x minus 3 to the 4th power. So if I want to solve these guys, if I want to solve x minus 4 squared equals to 0, I can raise both sides to the 1/2 power. So I get x minus 4 equals to 0, and I can add 4 on both sides. So that's a 4. For some reason my program likes to connect the lines on my 4s. So I get x equals to 4. And this 0 has a multiplicity, which I'm going to abbreviate MP equal to 2. Over here, if I want to solve x minus 3 to the 4th equals to 0, I raise both sides to the 1/4 power, and I get x minus 3 equal to 0. Adding 3 on both sides, I get x equals to 3. And this 0 has a multiplicity equal to that value of 4. It has a multiplicity equal to that value of 4. So they have two different multiplicities which are indicated algebraically by how many times they occur or the quantity of that exponent. So let's do the same thing for this example. So let us say we give you g of x equals to x minus 3 squared times x plus 4 cubed times x minus 3 to the 5th power. So be careful here. Notice in this example, if I were to set my polynomial, and that's a squared, if I were to set this equal to this is a squared, then I have x plus 4 raised to the 3rd times x minus 3 to the 5th. If I set this equal to 0, notice this term is the same and this term is the same. So when we have the same bases, we add their exponents because we know x to the m times x to the n equals x to the m plus n, which is the same thing. If you have x minus c to the nth power times x minus c to the nth power, this will equal to x minus c to the m plus nth power. So it's the same for terms as well, or binomials in this circumstance. So we would really write this as x minus 3 to the 2 plus 5 gives you a value of 7 times x plus 4 to the 3rd power set equal to 0. And it's imperative that you do this in order to determine the exact multiplicity, or the correct multiplicity. So remember what we said. This 7 and this 3, those values are indicative of the multiplicity that arrives from calculating those terms when set equal to 0. So we're going to set x minus 3 to the 7th power equal to 0. Solving this, we would take the 7th root or raise it to the 1/7 power, so I'll go ahead and show that. 7th root raising it to the 1/7 power, the exact same thing. So we would have x minus 3 equal to 0, add 3 on both sides, and we get x equals to a value of 3. And this 0 would have a multiplicity equal to 7. Setting this term equal to 0, we're going to get x plus 4 raised to the 3rd power equal to 0. We're going to take the 3rd root or raise it to the 1/3 power on both sides. So we get x plus 4 equal to 0, subtracting 4 on both sides, and we get x equals to negative 4. And this term has a multiplicity equal to 3. So this multiplicity is here, indicated by that exponent, and this multiplicity of 7 was indicated by that exponent.